Hello, welcome to module Building Physics as Imperative for Energy Efficient and Healthy Buildings. Since their first attempts to improvise their shelter, humans started to change the face of this planet more and more rapidly, especially after every industrial revolution. First shelters made of branches, stone and animal skin combined with first indoor fires for heating and cooking evolved into today's high-tech buildings. Materials, first natural with minor adjustments, in time became more and more processed and artificial. That made constructions bigger, cheaper, and the time of their production decreased. From the shelter, houses developed into machines with plumbing and wires in all walls, floors, and ceilings. As technology grew, we also became more demanding towards our building's equipment. As we had more gadgets, we developed a habit to spend much more time indoors. That development have brought us many advantages, but if we look deeper, more disadvantages, especially when it goes to our health. Every next generation had more problems with respiratory system, skin, eyes. We became tired, exhausted, unhappy. We blamed modern lifestyle, stress, food, and other obvious factors. Rarely we thought about the composition of building materials, their toxicity, duration, or later disposal. We packed the houses not only with toxic artificial materials, but also sealed and air-tightened them so the oxygen level was dropping while dust and toxic vapors levels raised. More and more gadgets became wireless and screens started to surround us in every corner of our houses and offices. The changes were even more visible on the surface of the planet. We started to scar the earth with logging, mining, quarries, water dams. Even worse situation is with invisible damages, ozone holes, soil degradation, water and air quality, meteorological incidents like floods, landslides, hurricanes. People in cities long ago started to notice that the outdoor air is polluted. So again, they found their salvation indoors, not realizing that an average household without air filters breathes the same air as outside, even enriched with toxins from their building materials, furniture, or other vapors. How did we come to this? The discovery of fossil fuels made enormous breakthrough, especially in building industry. From transportation of raw material, its processing into building material, transportation to site, building and life of the structure, everything seemed as a fairy tale that will never end. Non-expensive, easy to build, use and maintain buildings, combined with, as we thought, everlasting fossil fuel reserves, made building industry flourish and always ask for more. We changed our request from modest to highest form of luxury. We wanted our indoor spaces to be an optimal temperature all year round, and it didn't matter how much it cost. Nevertheless, the consequences of this rapid growth of building industry shortly led to the fact that it became number one trigger to climate changes. What went wrong? These three factors are the most responsible. Development of new materials and construction technologies, regardless of their origin, composition, toxicity, or lifespan, in haste with lack of time for testing. Non-compliance with climatic factors and microlocation, combined with increased requirements for thermal comfort, and various heating systems in buildings and cheap fuel to compensate their shortcomings, regardless of their efficiency, sustainability, and source. Affordable fuel from, as we thought, endless resources allowed us to tuck ourselves in our cozy, unsustainable homes. But in real life, the situation was different. Oil crisis struck the entire world, made fuel less procurable and more expensive. Once warm and comfortable homes became cold and humid with visible marks of different unwanted processes within the structure. All of this influenced the occurrence of construction and material damages, reduced vitality of the structures, health issues, financial expenses, and they resulted in development of regulations in the field of thermal, acoustic, and light comfort. Oil crisis in 1973 and 1979 led to further development of the applied science named building physics. According to Hans, building physics can be defined as the applied science that studies the hydrothermal, acoustical, and light-related properties of the building components. Understanding its principles is crucial for design of healthy and comfortable buildings, but also for their durability, energy efficiency, and affordability. The physical behavior of the building depends both on used materials and building technologies. To make it more simple, building physics is the science that speaks about how materialized buildings behave towards indoor space and environment and vice versa. In this module, we will speak only about hydrothermal properties. Thermal conduction is the feature of every material. The symbol for heat conductivity is lambda and unit is watt per meter Kelvin. And we can define it as the amount of the heat that passes through a layer of material 1 meter thick in 1 second perpendicularly on a surface of 1 square meters if the difference in the temperatures of its border surfaces in stationary state is 1 Kelvin. In other hand, in accordance with that, thermal transmittance U will be defined as property of a structure, and it tells us how much heat can be transferred from its one side to the other, and it depends on the thickness and lambda. It's expressed in watt per square meter Kelvin. The lower the lambda and U, the better. Heat transmission from one side to another is lower. In opposite to that, we have R value, thermal resistance of the structure, and its units are meter square Kelvin per watt. The bigger the thermal resistance, the lower the heat transfer. Staying indoors, we generate a lot of water in the air. Indoor ratio of temperature and humidity of air is important for sense of air and thermal comfort in space. Standards define water vapor diffusion as water vapor flow through a partition element or material as a result of the difference in water vapor concentration, as example as a result of the difference in partial pressures in different spaces. The water vapor molecules will try to move from the side of higher concentration to the side of lower concentration until a balance is reached. We refer to this migratory movement as water vapor diffusion. If our buildings doesn't have sophisticated ventilation system, then the diffusion will take place through the walls. That's called vapor permeability. Dew point is the place in structure where the water vapor condensates. If the window, wall, or ceiling is not insulated enough, condensation may occur in interior surface, making it wet. When the humidity moves through the structure, dew point can occur inside the wall, ceiling, or roof, and in most cases it will damage the structure. This topic is wide and complex, but we can conclude that the solution lies in good thermal insulation, installation of vapor check or vapor seal, but first of all, excellent understanding of the topic. We can say that thermal transmittance should rise from exterior to interior, and vapor resistance should go opposite way. In order to answer contemporary needs for healthy and sustainable buildings, some important changes in building practices were introduced. Return to climate, bioclimatic construction principles, respect of the natural conditions of the site and its microlocation, smart and sustainable design, taking care of orientation and shape of the building and optimization of energy consumption, a more caring attitude towards resources and exploring the possibilities of sustainable, bio-based or reused materials, and efficient and renewable energy sources for the entire process of building production, development of system of regulations in the field of thermal protection, introductions of new standards and certifications like Passive House, LEED, BREEAM, and others. Consideration of carbon footprint and pollution, environmental impact of entire lifespan of every used material and building itself. The future of building industry is in well-planned and built buildings. Our health and health of this planet depends on it. Modern approach to design of a building is holistic. Designers and engineers work together as a team. Instead of previous practice to work in phases, this team is now solving the problems in real time with a lot of brainstorming, and the process becomes more efficient and easier. Sustainable and responsible building industry is a key to a healthy urban environment. Thank you.